Welcome back. I'm Chris Sikora, and I'm here to take us on a journey through SolidWorks 2020 and Introduction to Sheet Metal. As you can see up on the screen here, I have a sheet metal part that's constructed, and it's like a hose bracket for mounting a hose on a machine or something. Anyhow, we're going to go ahead and take a look at how that's constructed. The idea here with sheet metal is once you've built it, you could go ahead and flatten it, and you get the flat pattern that you would actually be able to cut out on a plasma cutter or a water jet. So let's take a look at how that's built. First of all, go to File, New, Part, and hit OK. Select the front plane and start a sketch, and we're going to proceed to draw out the side profile. And it starts off, that circle in the middle is going to be a 2.5 inch diameter. So draw a circle on that front plane. And then go ahead and find center rectangle. And at the origin, click and drag out a center rectangle about 5 inches across. And let's dimension that 5 inches. And then dimension this at 1.5. And let me verify that. In the training guide, you could go to vertanu1.com. So V as in Victor, E, R, T as in Tom, A, N as in Nancy, U, X, 1. Don't forget that 1.com. Hit enter. And it's under instructional manuals and SolidWorks basics. Once you get there, it's going to be on page 108. Well, it starts a little bit earlier than that. Page 107. And you can see the parameters here. And sure enough, I made a mistake. 1.25. Now, we don't need to center it like it shows a dimension locating from this point to that point. We don't need to do that. But hit escape. Now, before we trim anything, sometimes it's better, especially if you're using a rectangle tool like that, or like what we see up on the screen, is to actually, if there's going to be an opening on that right side, we could actually not have to delete that line. We could just click on it and change it to construction geometry, and then it's innocuous for the extrusion. Now we could go to the trim tools, trim entities. You could use power trim or trim to closest. Trim to closest I think is easier on this one. Just delete these two lines, top and bottom, and then there's 6 additional little segments you're going to have to go in and delete, and surgically go in there and be careful not to hit the center lines because that's controlling our rectangle. Okay, I'm going to hit the green check. Now it might appear that this didn't trim. Now be aware that that's just the extension line off of this dimension. So if you pull it down, it's not there. So always look at the actual line font, the thickness of the line. If it's very thin, most likely it's just a dimension extension line. Okay, now we could go ahead and go to features, and actually no features, I'm sorry. We want to go to the sheet metal tab. Now the sheet metal tab may not appear on your screen if you've never used it before. What you need to do, if it's not showing up there, just right click on any of these tabs, go to the tabs, and find sheet metal and check it. And you can take a look there. Look at that. There's structural systems for structural steel, weldments, mold tools, mesh modeling. There's a lot of modules. You may not have all the modules that I have here. It depends on if your company has purchased SolidWorks Professional or SolidWorks, different versions of it. And if it's just the core SolidWorks, you will have sheet metal though. Everyone gets sheet metal. Okay, now that we're in the sheet metal tab, go ahead and select it. Go to base flange. Now, first of all, before we go any further, look at all these tools that you have. We're only going to scrape the surface of this one, just like we usually do in the intro class. In the advanced class, we have several sheet metal exercises. So those of you who are interested in more, definitely take a look at the advanced lessons, and you'll see that there's how to make cylinders, cones, lofted shapes. There's a lot of neat things in there. But let's go to base flange. Now we're going to go ahead and extrude this instead of blind, mid-plane. So because it's a symmetric part we want on both sides, or it's semi-symmetric. It's going to have some flanges that will appear shortly that we're going to add. But we want this to go be 2.5 inches wide. And again, let me verify that because I have a tendency to get this wrong. Oh, it's actually 1.5 inches. So 1.5. And hit the green check. Now, if you click anywhere on the screen, it'll get rid of that the blue geometry. Now, what we want to do is we want to put little bent areas on here, and what they call those are hems. So go to the hem tool and select, actually let's leave it on open just so you can see what it does here. If you select the bottom edge, now you want to make sure on the top flange, you want to select the bottom edge. Here, I'll zoom up. Because if you select the top edge, it'll fold upward. We don't want it to fold upward. We want it to fold downward in this case. And you can see that it's adding this very large radius. But go over here to the type and size and look at, they have several different types. We're going to go with teardrop. And that's a lot more manageable. It's 200 degrees by 0.00725. That's good for me. Now go ahead and select this edge on the top of the bottom flange so it folds up and around. And hit the green check. And so now we have two hems in there. So it's not quite as sharp. So if someone brushes against this, they're not going to cut themselves. All right, the next thing we're going to do is we're going to put in some holes in here. So go ahead and select this face right here and start a sketch. Now to center a hole, hit the little arrow to the right and find center line. And then from this corner here, make sure you get the orange dot in that corner. To this corner, go diagonally across. Now you could go to the circle tool and right at that midpoint on that diagonal line, draw a circle and smart dimension it. And just dimension it at a 1/2 inch. And now you could go to features, extrude cut, and select through all. All right, now we're going to go ahead and put a cut in this main area here. Let's say we wanted to keep this as light as possible. So we're going to open up that area, taking out some of the sheet metal. Let's go ahead and select the top plane, start a sketch, hit your space bar, and go to the top view orientation. Find the center point straight slot. Hit the little arrow there if you can't see it. Center point straight slot. Now at the origin there, click and drag this across, make sure it's horizontal, and have it go a little bit beyond the geometry here. Click and drag it out. We're going to make it a little bit smaller than what I did on my practice part. Now click and drag that out. And then let's go ahead and dimension this radius at 0.125. And then dimension the center line and make that 2.5. Okay, so we're intersecting a little bit. Now in theory, we could have actually patterned this, or we could still pattern it if we want, but we'll just put the one in here, go to features, extrude cut. Now if you rotate it, make sure it's going through all both and hit the green check. All right, so we have a little cutout in there. Now we want to put in a flange over in this area here. So let's go back to the sheet metal tab, go to edge flange, select the top edge here and drag it up a little bit, click, and now let's click on edit flange profile. Now don't hit finish yet, just drag this over out of the way. We're going to keep that up. Not until we're finished can we hit finish on there. So leave that alone, don't close it. Let's go ahead and we're going to select the Smart Dimension tool and dimension this width right here. And we're going to make this, oh, and unfortunately, it's locked in. Hit cancel there, hit cancel, hit escape. 2 times maybe to get out of the Smart Dimension. Now what we want to do first, before we just let it stay locked in place, is grab this line here and grab this line in here and drag them in a little bit. Now we could go to Smart Dimension. It was locked into position, so we'll make this 0.75, and then the height of the flange will make it 0.75 as well. Now let's use that little trick so we can center some through holes in there. So go to the Center Line tool and draw a diagonal line across, and then go to the Circle tool. And at the center, draw out a circle and Smart Dimension it, and we'll make these 0.375. Now, some additional things. Let's zoom up and see what we have here. Now, in the preview, we see a cutout. And what happens when you're putting flanges in? Think of it as if you've ever wrapped a gift for someone and you roll the paper over in corners, you see little ripples that will occur. The same occurs with sheet metal quite often. And so to make it a little bit easier during the fabrication process, they might put in these little cutouts. And what you'll find here, just hit the green check mark on dimension. And let's hit back. Okay, and here what we're looking for, first of all, before we hit that little cutout there, there's flange position. If you want it to go, right now it's going to material inside, so it's going to be flush with the face that we see there on the edge of the flange. But you have the ability to bend outside. There's bend from virtual sharps. There's material outside, things like that. But we're going to keep it right here. You have the ability to offset it too, or trim side bends. But now we have relief type. Check custom, or turn off custom relief type and hit the little arrow. Oops, you know what? Actually check it and then hit the little arrow again. Now you'll see rectangular that we have there is a cutout of rectangular shape. Now rectangular shapes for cutout for this relief, which is very common on sheet metal, again, so it doesn't ripple in those corners, is very useful if you're using any sort of machine that's going to cut this out, like for example a water jet cutter or plasma laser cutter for very thin pieces and things like that. Okay, because they could make that easy rectangle. Now what you don't want to use here is typically if it's going to be die pressed. Now they can still make it straight with a die. Now think of dies as, if any of you have ever seen the hole punchers for your paper, usually that's a die and it's circular, so it punches it out. And the wear is even on a circular shape versus on a rectangular shape. Where do you think it's going to wear out if you made like 1,000,000 punches with that? Think about it for a second. It's going to wear out at the corners first. So that's why there's another option here. So if you go with the process of manufacturing, you want to use round for die cutting usually. And again, your sheet metal fabricator will tell you the best solution that they like to use here. So don't necessarily go with what exactly I'm saying. I've worked on sheet metal before, but this is just what I've learned over the years. But really, they can make a straight cut, especially if it's not a lot of parts. If it's only just a few, it's not a big deal. Okay, and then finally, there's tear is another option. Now tear, oh, first of all, look at round there. See how it's radiused? It's rounded. But let's go to tear. Now, when I used tear, we were designing countertops for the food service industry and for the medical industry. It's out of stainless steel. And so the countertops, when you got to a corner, you wouldn't want to have a gap or an opening with an round or a rectangular area there, or else it would require additional finishing. Because imagine wiping off, if you're working at a restaurant and you're wiping off salad dressing or food product, it's going to get caught in those corners and bacteria can develop. So for the purpose of not leaving corners open and making it easier to fabricate, we usually went with tear. I'm going to go ahead and I'm going to go with round on this one. Hit the green check mark. And by the way, you saw that there was 90 degrees. We could have put it at a different angle, like 70 degrees or 45, but we'll keep it at 90 in this case, and you can see that right there. Now let's go ahead and get that on the other side. Now rather than recreating it, we can mirror it. Go to Features, Mirror, and select that face right there. Oh, actually mirror face plane. First we have to select this little arrow up here, go to the top plane. Now the features to mirror, go ahead and select that face. And you'll see it down below in a preview. Go ahead and hit the green check. All right. Now what we want to do is we want to see what this looks like in its flattened state, because some sheet metal fabricators will take your SolidWorks model and they'll do the rest from here on. But some of you might have to export this as a DXF for most CNC driven water jet cutters or plasma or laser cutters. So let's take a look here. Go back to the sheet metal tab. and go to Flatten. And there is our flattened pattern. So imagine this, those of you who aren't familiar obviously with sheet metal, think of it, most of you have assembled a box before, like the corrugated boxes. And essentially that's what you're doing here. When you see the box in its flattened state and then you have to fold it, sheet metal works very similar to that. Okay, and let's go ahead and fold it back up. Now we're going to go ahead and save this, and go ahead and save that. This is E11, and I'm going to save it in my SolidWorks Basics folder. Oops. Let me go back there. I'm going to call it E11B and save it. All right, now to get the DXF file to export to a laser jet or water jet laser or plasma cutter, go to File, and you're going to find Make Drawing from Part. And you want to go with something large enough because you don't want them to have to scale it. Yes, they can scale it, but then you have to give them the information on how the overall length is. To make it easier on the fabricator, you give it to them in scale. So they don't have to, and there won't be any mistakes that way, hopefully. And what you could do, you could go with custom sheet size, or you could just select, like in this case, this is, just to be on the safe side, I'm going to go with the D size sheet. And if you go with a custom sheet, you could eliminate the actual border. Let's go with that maybe. Yeah, 34 by 22, that should fit it. Hit OK. And so it should not put a border in because otherwise they might have to remove the border. Some old software systems required the border to be removed as well as other features. Now, as you can see over here on the right, you have the flat pattern, the upper right corner. Go ahead and drag that in and release it. Make sure, hit escape and then click on it. And just make sure that it's a 1-to-1 scale. So if you go to scale here, look at that, it made it 2-to-1. So let's turn that off and find 1-to-1 scale. And SolidWorks has its own algorithm built into it. I guess we picked too large of a sheet, but that's okay, it doesn't matter. SolidWorks has an equation that looks at the size of your part, and it looks at the sheet size, and it calculates how it could comfortably fit front, top, and right views. We're not interested in that, but it still takes advantage of it there. And so it scaled it to 2-to-1, which is twice the size. All right, now you can also see here, it put in all this other information. Again, sometimes your fabricator does not want to see that. You can actually click on these. You can either hide them or delete them. Hiding might be a nice option just simply because you could always bring them back. I'm going to control select them and then hide them. Now I could right click and hide. As far as these lines go too, you have the ability to go in there and hide those if need be. Again, the sheet metal fabricator, depending upon their software, most recent softwares will enable them to work around those extra lines. I've worked with some though that didn't want anything. They just wanted it all blank. So like even these sketches and such, if we could find those would be, I believe, in the flat pattern. Some of these sketches, if we hide them. Oh. There we go. So the bend lines, when I right clicked it, hid those. And then the center marks, I think you might have to do them individually. There might be a way to hide those all too. I bet you it's under a standard option. If someone sees it, go ahead and post it below in the comments. And there you go. In this case now, it's completely stripped of everything. It could go right into as a DXF. But here, oh, one last thing. I have to do a file, save as, and let's update it. Let's see what it does. Okay, instead of a SolidWorks drawing, there is DXF. DXF stands for Drawing Exchange Format. It's one of the earliest neutral file formats that's 2-dimensional. And so almost all of the laser jet laser and plasma and water jet cutters, except DXF. If they ask for something else, you can provide it. SolidWorks has basically all of them there. And you just hit save. There are some additional options in here for that. You could save it for different versions that are compatible with AutoCAD, as a DWG. You could enable export as splines or as polylines. Older machines might require polylines, so you would select that, and it breaks up curved geometry into a collection of little lines. And older machines in particular from the 80s or 90s might require that. Anything in the 21st century here should accept splines for the most part, as far as I know. But again, talk to your sheet metal fabricator and see what they need. And this is just a nice courtesy to do these things for them because they've got a lot going on. All right, now what I want to take a look at here is the next exercise, sheet metal. This next exercise is actually building, working inside the context of an assembly. We've been dealing with assemblies for the past couple of weeks. Top down, which was exercise 10. I'm sorry, that was a hybrid, basically top down and bottom up. We did bottom up with exercise 5. And then now we're going to do this one. We're going to build the sheet metal enclosure around that gear assembly, the gear and belt assembly. And let's say it's for safety purposes. And I'm going to show you some neat techniques here. So go ahead and click on this one and let's hide it. And we're going to reconstruct that. I'm going to go through how. So here we have our assembly. We have a casting there that's holding into place those gears as well as the belt and pulley. And I'd like you to go to Assembly, go to New Part, and just select the front plane. Now the front plane just so happens to be aligned to these end faces, which is perfect for us. So it's already opened up a sketch. We could actually save this as a new part. In fact, let's go to File, Save As, hit OK there. And let's save it as our E11 SM for sheet metal cover, just so you know it's yours. And save it with there, wherever you like, or with the assembly is preferable. I didn't really look where I was saving. But now, select this face. We want to encompass that geometry. So select this face and hit Convert Entities. Now that makes it equal size as the casting of that green face that we selected. Now let's go to Features, Extrude Boss Base. Now the technique I'm showing you, there's users that have been using it for a decade already, SolidWorks, who don't even know the technique I'm about to show you. This goes back to 1997. When I first started with SolidWorks, they introduced sheet metal in their third release, which was in 1997. And this goes back to then. And so it's kind of a forgotten method, but I think it's really cool. And I think you'll like it too. So if you're doing this and someone's kind of like, what are you doing there? You could say, this is an ancient secret that dates back to the 90s for SolidWorks. Okay. Anyhow, let's go ahead and click on this back edge and it will extrude up to that back edge automatically, which is fine. Now notice I'm not in the sheet metal tools yet. I'm just extruding a solid over it. That's what makes this so interesting, is that I haven't even touched the sheet metal tools. I'm just using standard modeling tools. So I have this solid over it, which I'm going to turn into an enclosure in just a moment. But let's go ahead and click on it and go to Open Part. We're going to separate it outside of the assembly just temporarily. Hit your F key on your keyboard and keep it at this view orientation. Now what we're going to do, we're going to go to the shell command. Again, not doing anything sheet metal related just yet. Keep it at, let's put it 0.062. Now 0.062 could vary as a gauge. I've seen it with, I believe it's aluminum. It could be considered 12 gauge with steel. I believe it's 16 gauge. I can't remember, or maybe it's vice versa. Anyhow, we'll go with 0.062. And the faces to remove now, we have to select this one here, and that one. Now there's one more on the other side, and you can either rotate to get it, or you could get your pointer in this upper left corner near, right click, and use the select other tool. Now this is the second time I showed this to you. A couple weeks ago I showed it to you in another tool. But go to select other, and it should only be one face back there. Select it. So we didn't even have to rotate it. You could rotate it if you like. Honestly, if I were doing this in real life, I probably would have rotated it, because right-clicking and then selecting that is actually a little bit more work to me than rotating. So go ahead and hit the green check. And you can see now we've shelled it out. But it's not a sheet metal part yet. It can't just flatten right now. We need to give it the instructions on how to do that. So go to the sheet metal tab and go to, now here's the thing, insert bends. It's not used by a whole lot of people, actually. I found I've done SolidWorks World. Last time I did SolidWorks World was 2010, and I talked about this. I actually showed this demonstration. And there's the rip tool too. Now the rip tool is still used quite often, but let's go ahead and use that first. Go to rip. Just so you know, rip is integrated into insert bends. So we could have done this all in one shot, but I want to show it to you separately to break it down to make it easier to digest. So rip parameters. Select this edge right here, and you'll see a double arrow. Select this edge over here, and you'll see a double arrow. If you either hit change direction for those, you'll see the arrows flip around. You can actually click on the arrows and get them to flip too, but one of the downsides is that you can't get the double-sided arrow, again, unless you hit change direction. So just be aware, and you select them from this list. The double-sided arrow actually makes a complete notch out of the corner. So let's see what that does. We're going to keep it at 10,000ths of an inch, which is the default. Now look carefully here. This is a corner that's currently not open, but it will be. Hit the green check, and it notched out both of those ends. Now let's, and you see it goes all the way down, and then it stops. Now let's see what happens if we alter that. So edit the rip by clicking on it, go to edit feature. Now hit change direction. We got to, actually let's go back to this view here. Change direction so that the arrows are pointing up towards this face. Now hit the green check again. Let's take a look at what we just did. Look at that. It actually followed this surface as if it were cutting down and used that surface as a jig, where it took like a hacksaw blade, cut it through. So it's not a complete notch out. Let's try another one. Right click on it, edit feature, rotate around. You could click on the heads, flip them, and see what this does. Now rotate, and now it's using the adjacent face, the perpendicular face, as the jig where it's actually cutting down. So, and I just use jig, the term loosely. Those of you in manufacturing typically know what a jig is, but it's not really a jig. It's just, I'm just using that as an example. It's following that surface if you were to cut. Okay, but let's go back, edit the feature, and let's click on edge 1, hit change direction till you get both arrows. Hit edge 2, change direction till you get both arrows. Hit the green check. We're going to completely notch it out. Otherwise, you can't see what I'm about to do very well. So you could leave it if you like. Sometimes I've gotten error messages because it's a little too complex because it's a tight corner if you leave one of those on. But now that we've got this, we can now go to insert bends, and we have to select the main face that's going to be, as they call it here, if you hover over it, the fixed face. That's going to be immovable. Everything else is going to unfold around it. Now, the bend radius, 0.12, that's okay. We could go a little tighter. Let's go 0.07. Oops, I got too many decimal places. Notice it turns red when you do that. And you know, a fabricator might not like me for that one. Let's go 0.06. Wait, that's the thickness. And let's go with 0.1. Let's just go with 0.1. Okay. All right, now the bend allowance. If you hit the little check mark here, you'll see there's K factor as a default. There's bend table, bend allowance, bend deduction, and bend calculation. What these are, if you ever want to know what they, and the equations that go along with them, click on the little question mark while you're in it right here. And the question mark up here is the help. And it will bring up SolidWorks help, which is really quite nice. Now look at this over here on the right, K factor, bend calculation, auto release, bend table. Let's go with K factor. Here you could see what's involved with the K factor. Those of you in sheet metal fabricating know what this is already, most likely in the United States, especially I know here in the Midwest, it's very commonly used. You can see it's here it is. Bend allowance is equal to pi times radius plus kt, which kt is the k factor, which is t. You can see the distinctions, the capital T and the lowercase t, which is considered the center of that point, but that could vary. All right, I'm not going to go into this because those of you in sheet metal fabrication know what you need. Those of you who aren't, contact your sheet metal fabricator, ask them what they want. Okay, the sweet spot for the K factor, it defaults to 0.5 every time, but I believe, oh gosh, I can't remember what the sweet spot that I've been told before out there is not necessarily 0.5. I believe it's 0.334 or something like that. But make sure that your fabricator knows. Because if you leave it at 0.5, I've had customers back in the day when I used to work with sheet metal who were like, oh my gosh, everything's coming out 30 thousandths too large. And then once we adjusted the K factor, and I believe it was 3.34, but again, verify that. That's just my experience with one fabricator. You know, it came out correct. So definitely you can look into that. Now, there's other things too. There's bend allowance, which that's an explicit value. Oh, didn't want that to go away. Let's click on that again. And let's look at the bend calculation table. And here you can see that, how you could insert that type of information. There's also bend allowance and bend deduction. And this is an equation. And I'm told that in Europe this is used. I was told by one of my students years ago. I've never seen it here in the United States, but I think he was from Poland, and if I recall correctly, he mentioned that he'd seen that. So anyhow, then there's bend table. And bend tables, you could see, you could specify your units, millimeters, bend type, the material type, soft copper and brass, and that could vary for whatever material you might use. Where I saw this back in the day when I used to be a SolidWorks tech support person, I used to go out to fabricators, and it was quite often in the 90s. They were trying to convert their tables over, and what they had these old 3-ring binders, and you know the sheets were laminated, and they would go through, and they had tons of these things that had to be entered in. And what I discovered is that the angle, and most of them were the opposite of what the angle that SolidWorks required. So you just have to, you just have to reverse it if it's over the 180 degrees. So anyhow, just be aware that might be a little bit of a challenge, unless they've changed it as of recently. I'm not sure. Okay, but you can look up those different items. We're going to keep the K factor at 0.34. And then auto relief, we'll leave it at rectangular. At 0.5 is fine. 0.5, the relief ratio basically makes the width and the depth of half the sheet metal thickness. And then the rip parameters, that's where our rip, we could have done this all in one shot. We don't need to do it because we already did it. So hit the green check. And this is not an error message. Auto relief cuts were made for one of our bends. Look at that corner. It really gouged it out. So anyhow, so we could see, now let's go ahead and try and flatten that. Hit flatten, and there's your flat pattern. Okay, let's hold control and hit tab. And what you might notice here is that there's an intersection. I'm going to have it update, and I'm going to hit yes. The actual model is intersecting with this geometry. So what I neglected to do, let's hold control, hit tab, go back. Now we have to go look at the shell. Click on the shell and edit the feature. And click on shell outward. Hit the green check. Now control tab back. And yes, let it update. And now it's actually overlapping. Now be aware there's a little area there on the casting, should have actually a fillet on it. I never put that one in there. But anyhow, there you could see it's bent around it. So we've successfully made our enclosure. Okay. And if you wanted to close off this backside, you could do that. And I'm just going to show this to you. You could use the edge flange like we used earlier. Select this edge for it to stop at. Now, you'll notice it's intersecting, so this is where you need to use material outside. Okay, and hit Edit Flange Profile. And now what we could do is we could steal these edges where there's screws that need to go into those areas and hit Convert Entities. And now you can hit Finish. And now we've actually matched up those holes. Now there are some holes at the top here that I neglected to do too. So select this and start a sketch. Because currently we're editing that enclosure. See, it's blue. We know that if the text is blue, that's the part we're editing. So if you're not, make sure that that's turned blue. Remember, Edit Component allows you to toggle it on and off. Okay, so we're sketching on here. Let's go to Hidden Lines and select this edge here. And Control select this edge, hit Convert Entities. Let's go back to Shade It with Edges. So now we have the circles, but we have to come through. So go to Features, Extrude Cut. And now they have something called, when you're working with the sheet metal, Link to Thickness. And this actually showed up in the last exercise as well. Link to Thickness is a really nice tool because what it does is it only goes through the one layer of sheet metal. Now, last time we used through all because we wanted to go through 2 layers of sheet metal. Okay, so that was a little different, but Link to Thickness will only go through the 1 layer of sheet metal. You also have normal cut, and normal cut doesn't really make a difference here, but if, like for example here, if we were to actually draw a circle to cut through, if you cut it through at this angle that is currently sitting at, and we flatten it, you would have the hole, if you looked at the cross section of the hole, it would look like this. It would have angles on it. You'd have sharp edges at the top and at the bottom of the other side, because it turns almost elliptical. So what that tool does, normal cut, will straighten those out, projecting through the actual circle to both sides. So when you flatten it out, it's straight. So it's on by default. So just be aware, sometimes you might want to turn it off. If you're fabricating in the folded state, you might want to turn it off. But if you're fabricating in the flattened state, you ought to turn it, leave it on. Hit the green check. All right, and that, the lab for this is to make a drawing of this model here. So go to File, actually we'll have to save it. And now we go to File, Make Drawing from Assembly. Oh, and I forgot to explode it. Well, that's all right, we'll go back. That's a good thing because a lot of times you forget to explode. I'm gonna show you how you can go back and explode it. Or I should say, make an explode view. We're gonna go with standard sheet size. I always recommend for something that you might want to print out for your portfolio, keep it at A size. For me, if you're going to send it to me, give me an A size so when I print it up, I can mark it up. I don't have a plotter at home, especially if I'm grading from home. Okay, hit OK. And oh, we actually do have an isometric exploded, but I'm going to show you how to fix that. Actually, I'm going to hold Control and hit Tab. Now to explode this, I'm going to go to the Turn Off Edit Component and go to Exploded View. I'm going to select this and grab the Z arrow. Make sure the Z arrow turns blue before you do this. Drag it forward. Now hit Done. Click on this casting. Drag it backward. And that's all. Hit the green check. Now let's add the Exploded Line Sketch. Click on Exploded Line Sketch. Select this edge here. Make sure you flip that arrow so it's pointing towards this. And click on that edge, hit Apply. This edge, flip the arrow. This edge here, hit Apply. Actually, if you select the face, you still have to select the arrow, and now it's stuck in there. So I'll just hit Reverse. And let's see if we select that edge there. So the line doesn't go all the way through. Hit the green check. Now, if you need to, you could delete these. You can click on them and hit delete on your keyboard if you're unhappy with the way they turned out. But let's go ahead and save this. Rebuild. And now let's Control Tab back to the drawing. And click on the View palette. Now grab the isometric exploded, and all of a sudden you see it's like, oh, that's not my isometric exploded. Well, this is because I changed it. There was an original one in there. So go over here to the explode view and select the second one that's on the list. And there we go. Okay, and click on this, and then let's shade it with edges. Now let's go back to the view palette and grab the, let's see here, let's grab this front one right here. And unfold a right and a top and a left. Hit escape. I know I did a little bit different in the actual book. If you do this, this is fine. I think I actually do a section view and such. This is good enough. Now click on this, and if we want to see hidden lines, click on hidden lines right there so we can see the internal, as well as this one. Click on hidden lines. And that's pretty good. And let's put an inspection dimension just for good practice. So select this bottom edge here, top edge, click, and go to inspection. Click on this edge here, to this edge here. You might have to zoom up because there's multiple edges that are very close. Click there. Let's go and add an inspection dimension there. Okay. And then just put your name on it right there. And that concludes exercise 11, sheet metal.